Hi everyone, so today we're going to be working out a problem using Newton's law of cooling, and the problem reads, just before 6 p.m. students enter the classroom to find Mr. Fies dead of an apparent homicide. At 6 p.m. the temperature of the body is 80 degrees, while at 7 p.m. it was 75 degrees. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? So we're going to be working with this formula, Newton's law of cooling. And we're going to start with part A, which is to find the decay coefficient, otherwise known as K. And to do this, I'm going to equal 70, which is the constant temperature, or the T ambient, plus 80 minus 70, 80 because that is the temperature of the body when it was discovered, e to the negative k times 1 because it's been exactly 1 hour from 6 to 7 p.m. And because of that, I'm going to equal this whole thing to 75 degrees because that was the temperature of the body at 7 p.m. after the hour had passed. I'm going to subtract 70 on both sides and get 5 is equal to 10 from subtracting 80 minus 70, e to the negative k times 1. And from here I'm going to divide by 10 on both sides, and I'm going to get 1/2 is equal to e to the negative k times 1. And now, to be able to bring the exponent down and work with it, I have to find a common base, and to do that, I'm going to take the natural log of both sides. So I'm going to take the natural log of 1/2 and equal it to negative k times 1. And to be able to get the negative out of the k and work with the 1, I'm going to divide by -1 on both sides. So k is equal to the natural log of 1/2 divided by -1, which is approximately equal to 0.69315. And that is the decay coefficient that I'm going to plug back into the equation to find how much time passed from the time of death to the time of discovery for part B. I'm going to take 98.6 because that is the average body temperature before death, equal it to, again, the constant temperature 70 plus 80 minus 70, e to the negative 0.69315 times t. From here I'm going to again subtract 70 on both sides and get 28.6 is equal to 10 from subtracting 80 minus 70 again, e to the negative 0.69315 t. I'm going to divide by 10 on both sides and get 2.86 is equal to e to the negative 0.69315 times t. And again, to find the common base, I'm going to take the natural log of both sides. So the natural log of 2.86 is equal to negative 0.69315 times t. I'm going to divide both sides by k. Therefore, t, or the time from death to discovery, is equal to the natural log of 2.86 divided by negative 0.69315, and this is approximately equal to negative 1.5, which can also be interpreted as 1 hour and 30 minutes from the time of death to the time of discovery. And this is going to lead us into part C. Part C is to determine the time of death. So to do this, I'm going to take 6 because the body was discovered at 6 p.m. I'm going to subtract because it's negative 1.5. And this gives me 4.5. That is going to be equivalent to 4:30 p.m. And it was at 4:30 p.m. that Mr. Fies was murdered. Thank you.